On October 24th, 2025, at 14:32 UTC, something impossible happened. At the MeerKAT Radio Observatory in South Africa, across the screens of engineers and scientists, a signal appeared. Not from empty space, not from a distant star, but from a comet. An interstellar comet named 3I Atlas. The signal was broadcast at a frequency of 1,600 MHz. 4 hours later, it repeated. Then again. Not random knocking, but a clear, defined, structured sequence. And here's what shook the scientific community. According to every current mathematical model, this signal should not exist. No interstellar comet entering our solar system has ever broadcast a radio signal at this frequency. 2 comets before, Oumuamua in 2017 and Borisov in 2019, were completely silent. But 3I Atlas spoke. It spoke, and then all raw data was stamped internal use only. All of it. Within 6 hours. So why? And who or what made it speak? To understand why this discovery is impossible, we must go back to history. And to understand history, we must know the people who were listening, those who had waited so long, those who once believed that one day the universe would answer. Dr. Marcus Chen, 52 years old, head of the radio astronomy team at MeerKAT, has devoted 24 years of his life to listening. Since his days as a doctoral student at Stanford University, Chen believed that if anything out there, anything at all, exists, it would speak to us through radio waves. Radio waves know no boundaries. They pass through cosmic dust, through gas clouds, through time. If you know how to listen, radio waves will tell you every secret. But in October 2025, after 2 decades of listening, Chen still hadn't heard anything worth mentioning. Oumuamua in 2017, silent. Borisov in 2019, silent. The scientific community was gradually growing weary. Wandering stars sent no signals. Interstellar comets, potential messengers from other systems, were silent too. Nothing was happening at all. MeerKAT sits in the Karoo, a desert in South Africa, one of the quietest places on Earth from a radio perspective. At 1,760 meters elevation, far from every city, every transmission tower, every noise. The enormous array of 64 antenna dishes, each 13.5 meters in diameter, are arranged like giant flowers pointing skyward. They were designed to hear the most modest voices from the universe, incredibly weak signals, sequences of low-energy photons, things that most other equipment would dismiss as noise. Dr. Sarah Okonkwo, 38 years old, an astrophysicist from the SETI Institute in Bay Area, is Chen's colleague. She is a specialist in comet chemistry and spectroscopy. Throughout September and early October 2025, she analyzed every piece of data from optical telescopes worldwide. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, the James Webb Space Telescope in orbit, all tracking 3I Atlas as it drew closer to the sun, and all reported something strange, no tail. No, or if there was one, it was very faint, very unusual. A normal comet, as it approaches the sun, should create a magnificent tail, dust and gas streaming from the heated surface. pushed by sunlight into a great arc trailing behind it. But 3I Atlas? It was just a small, bright, oddly shaped blob. Strange coloration. Bluer than expected. Colder than expected for its distance. A reference in Chen's private files, a note from a retired Japanese astronomer, someone he hadn't seen in a decade, stated, "In 2019, I saw something in Borisov, something small. I wasn't sure. I didn't report it. I didn't want to look crazy. I didn't want to look crazy." Chen read those words 100 times, and each time a chill ran down his spine. On October 10th, 2025, JWST, the James Webb Space Telescope, one of humanity's most sophisticated instruments, observed 3I Atlas in infrared wavelengths. The data seemed anomalous. One side of the comet was warmer than the other side asymmetrically. We're not talking small differences, we're talking 30 to 40 Kelvin. A massive gap. It suggested unbalanced outgassing activity. Or, and here's what most scientists refuse to say aloud, it suggested something inside the comet was generating its own energy. The entire large scientific community looked at the same data set and saw different things. Some saw an unusual but certainly natural comet. Others saw unusual enough to warrant further investigation. And a small few, these scientists would soon be isolated from official conversations, began wondering if it could be anything but natural. On October 20th, 2025, Chen made an unusual decision. He directed his team to aim MeerKAT at 3I Atlas. Not because he expected to find anything. He still hadn't reached the point of accepting that Borisov or Oumuamua broadcast radio signals, but the early indicators from optical observations, they suggested something unusual was happening. And if unusual, then certainly worth looking at. The observation window would be very narrow. After October 30th, 3I Atlas would disappear behind the sun from Earth's perspective, a phenomenon called solar conjunction. It would be hidden for 2 weeks. Afterward, when it returned, it would be much weaker, too weak for ground-based instruments to detect. So October 24th was one of the last chances. The sun would be particularly close that day, only 3.76 degrees away. Most astronomers avoided such observations. The sun is an enormous electromagnetic furnace creating enormous noise at every frequency. But Chen knew that if he waited, it might be too late. At 1432 UTC, MeerKAT aimed directly at the comet. And MeerKAT heard a voice. To understand why a signal from 3I Atlas is a major shock, we must look at a sequence of facts. Specific numbers, precise dates, coordinates in space. Science doesn't speak in flashy words, it speaks through data. Everything began on August 15th, 2025, at 0314 UTC. An automatic optical telescope called Pan-STARRS in Hawaii detected a new object in the night sky. It wasn't very bright, only visual magnitude 15.2. But its orbit? Its orbit had one very distinctive characteristic. It was hyperbolic, not a closed ellipse that would bring it back to the solar orbit. A hyperbola means it came from infinity, from outside our solar system. This confirmed that 3I Atlas was an interstellar visitor. 3 days later, on August 18th, astronomers began analyzing its spectrum, its chemical signature. They found hydrogen cyanide, HCN, carbon dioxide, CO2, and traces of nickel vapor. These are the molecules you'd expect from a comet. compounds created billions of years ago, frozen in the cold universe, now beginning to vaporize as the comet approached a different star. But the details began not to match. From late August through September, observations from the Keck Observatory in Hawaii and the Very Large Telescope in Chile revealed something strange. The comet had no magnificent tail that we expected. Or it did, but very weak, very uncharacteristic. A normal comet, as it approached the sun, should release tons of dust and gas. But 3I Atlas, it was just a small, bright blob with odd morphology. The coloration was also unusual. Observations showed a color index, BBV, around 0.15, very blue compared to other comets. This suggested either a very bright surface or a different process was generating blue light. Normal comets are red or brown. They accumulate dust. Dust tends to be red. But 3I Atlas, it was silvery pale blue. As we entered October, the James Webb Space Telescope, an instrument astronomers had dreamed about for years, searched for 3I Atlas in infrared wavelengths. Data came back, and that data showed something completely impossible to explain with normal comet models. One side of the comet, the side facing the sun, was roughly 35 Kelvin warmer than the other side. That's an enormous difference. If it were just a simple round comet being heated by the sun, you'd expect relatively uniform warming. But this wasn't like that. JWST data showed a concentrated hotspot in a small region, suggesting either a vent releasing hot gas in one direction or something inside the comet generating heat of its own. When we examined the orbit, everything became even clearer and stranger. The heliocentric velocity of 3I Atlas, the speed at which it moves relative to the sun, was approximately 58 kilometers per second. That's fast. It's faster than Oumuamua, by 26 kilometers, and faster than Borisov, 32 kilometers. The perihelion distance closest approach to the sun occurs on October 29, 2025 at approximately 203 million kilometers, or 1.36 astronomical units. But here's what troubled every astronomer: orbital deviation. When astronomers predicted where 3I Atlas would be based on early observations, they could calculate precisely. But when it actually arrived, it wasn't where predicted. It shifted, not tremendously, but enough to detect from the expected orbit. This is called non-gravitational acceleration. The underlying meaning is simple. If only the sun's gravity acted on it, it would be in the right place. But it's not. Something else is pushing it, or pulling it, or changing its orbit. Normal explanation: gas jets from the comet's surface could create tiny propulsive forces like a small rocket expelling gas. But the non-gravitational acceleration we observe in 3I Atlas is too large and too consistent to explain through random outgassing. It suggests something systematic, something controlled. On October 20th, an astronomer from a research institute in China sent an informal email to Dr. Chen. The sender claimed his team detected a faint pulse sequence at 400 megahertz from 3I Atlas on October 18th at 22:15 UTC, but they assumed it was interference from a Chinese satellite. So they didn't report it. They remained silent. The next day, October 24th at 14:32 UTC, MeerKAT detected a signal at 1600 megahertz. But now, with data from China, data that would only become public months later, it became clear that 3I Atlas wasn't signaling for the first time. It had broadcast previously at a different frequency. The spectrum from MeerKAT was very clear, a sharp peak at 1/600 Mars. But when astronomers looked more carefully, they saw something else. Very small absorption lines at 1.665 MHz and 1.667 MHz. These are characteristic frequencies for hydroxyl radicals, what forms when water vaporizes and water molecules are split by ultraviolet radiation from the sun. Light from the comet at these frequencies would be absorbed by these molecules, creating dark lines in the spectrum, the unique chemical fingerprint of water. But the estimated water production rate from these absorption lines, it was 5 to 8 times higher than what models predicted for a comet of 3I Atlas's size at its distance. This could be explained if, first, the comet has an internal energy source, perhaps a hot core, or second, it's not just a natural comet. In total, when we stack all these facts, hyperbolic orbit, blue color, no tail, thermal asymmetry, non-gravitational acceleration, radio signals at unusual frequencies higher than expected hydroxyl radical production, a picture begins forming. Not the picture of a normal comet, the picture of something mainstream science wasn't ready to accept as truth. Now we come to the question every scientist must ask when faced with extraordinary data. If not natural, then what? 4 main hypotheses have been proposed to explain the data from 3I Atlas. Each hypothesis has its own logical foundation, but each also has gaps. Hypothesis A: an unusual comet from another star system. This is the explanation preferred by mainstream science. According to this hypothesis, 3I Atlas formed under special conditions. Perhaps its original star system once experienced a collision or geological event. This could explain why it contains metallic materials, nickel vapor, and complex compounds like hydrogen cyanide, materials requiring heating and reprocessing in the past. Support for this hypothesis: comets can undergo complex internal processes. A core heated by radioactive decay could exist in very old comets. Metallic materials suggest primordial heating. All these facts, if we ignore other data, could be explained through natural physics. Problem: this hypothesis doesn't explain the 1,600 MHz radio signal. Normal gas outgassing from a comet doesn't produce radio signals at L-band frequencies. This hypothesis also doesn't explain why hydroxyl radical production is 5 to 8 times higher than predicted. And it doesn't explain the systematic, not random, non-gravitational acceleration. Hypothesis B: a hot core or internal geothermal activity. If 3I Atlas has a core kept hot by radioactive decay or another geothermal process, it could maintain something like an internal engine. Such a core could generate higher than normal gas pressure, leading to asymmetric outgassing. It could also explain the thermal asymmetry that JWST detected. Support for this hypothesis: JWST data clearly shows one side warmer than the other. Orbital data shows non-random acceleration, it's systematic. A hot core would naturally explain these facts. Problem: such a core would need to have been created by an extremely rare event, a direct collision or special reprocessing. This type of core doesn't match what we know about comet formation, and it still doesn't explain the radio signal. Why would a comet broadcast radio signals at 1,600 MHz and 1,400 MHz, very specific frequencies, if this resulted only from natural outgassing? Hypothesis C, a constructed or modified object. This is the hypothesis most scientists would dismiss immediately. But when we consider the data, radio signals at specific frequencies, no tail, systematic acceleration, it cannot be entirely ruled out. If another civilization, or an unknown natural force, had interfered with an interstellar comet before it entered our solar system, they could have rebuilt it or activated signaling capabilities. The 1,600 MHz signal is not random. It's a frequency any technical civilization would choose because of its properties. It falls within the Waterhole window that SETI has used since the 1970s, a frequency range any civilization would recognize as ideal for transmitting information. Support for this hypothesis: the signal has structure, not random noise. The gas-to-dust ratio is too perfect, as if optimized. No tail, as if designed not to look like an ordinary comet. Problem: no direct evidence. Violates Occam's razor, the principle that simpler explanations are usually correct. If we start assuming alien technology, we'd see alien technology everywhere. Hypothesis D, a form of non-human life or intelligence. This is the final hypothesis, and perhaps the craziest. But think about it. The signal from 3I Atlas is not random knocking. It has structure, it repeats, it broadcasts at a very specific frequency. If a form of life or intelligence could exist inside or on the surface of a comet, a form of life protected by the outer layers of water ice from cosmic radiation, it could use radio signals for communication when the comet approached the sun and conditions became more favorable. Support for this hypothesis: the signal exists and has structure. It began when 3I Atlas approached the sun, precisely when conditions would become most favorable. It wasn't broadcasting before, at least not at detectable levels from Earth. This suggests something was activated or awakened as heat increased. Problem: no evidence whatsoever. It requires a major revision in biology as we understand it. It requires us to believe that life, any form of life, could exist inside a frozen comet. But mainstream science is not silent. Those defending it, established scientists with reputations to protect, they have answers. They say, you're misinterpreting the data. Mainstream argument about the radio signal. Regarding the 1,600 MHz signal, mainstream science has built a logical case. That signal, they say, could result from complex interaction between the solar wind, transmissions from Earth satellites, and unusual ionospheric conditions over Kourou. MeerKAT is not inside a vacuum box, it's on Earth. It's surrounded by electromagnetic noise. Although it's in a quiet zone, it can still receive complex interference from nearby and distant sources. Furthermore, they argue that hydroxyl radicals could be created from completely normal photodissociation processes. When sunlight strikes water ice on the comet's surface, some ultraviolet photons have enough energy to split water molecules. This isn't an unusual process, it's fundamental physics. So the hydroxyl lines at 1.665 MHz and 1.667 MHz It can be completely explained. But if photodissociation is normal, why is the production rate 5 to 8 times higher than predicted? Mainstream science has an answer for this too. The comet simply has an unusual surface. Perhaps it has a very reflective surface, a bright surface that enhances photodissociation. Or perhaps it has a thicker layer of water ice on the outside than we expected. This is not extraordinarily unusual. Comets can be quite different from each other. Mainstream argument about thermal asymmetry. Regarding JWST data, the thermal asymmetry we observed, mainstream science has an explanation. It could result from calibration errors or improper smoothing in the data analysis process. JWST is an extremely sensitive instrument. It requires precise calibration. If engineers used an inappropriate smoothing standard when processing data, they could create artificial anomalies. Defenders of this argument point out that data processing software is not perfect. It contains small errors. Those small errors could be amplified by unwise choices about smoothing standards. So the thermal asymmetry we see, it could just be an artifact of the data processing. They also argue that even if the asymmetry is real, it could still be explained by asymmetric gas outgassing from the comet's surface. If the comet rotates and only one side is illuminated by the sun, that side will be warmer. This is elementary. It doesn't require a hot core or anything unusual. Mainstream argument about orbits. Regarding non-gravitational acceleration, mainstream science says they completely expect this from an active comet. Gas outgassing, what we call outgassing, creates tiny propulsive forces. These forces will slightly change the comet's orbit. That's not unusual. That's normal. They point out that other comets in our solar system, ones we know are natural, also show non-gravitational acceleration. So if 3 Eyes Atlas shows this, it simply means it's an active comet. Common ground between both sides. Here we must pause and acknowledge something important. Mainstream science is not entirely wrong. In fact, some of their arguments are quite logical. Both sides agree that 3I Atlas is a real object from outside our solar system. Both sides agree that the signal from MeerKAT is real and was recorded properly. No instrumental error. Both sides agree that the data deserves further investigation. They only differ in how they interpret the data. But there are gaps in the mainstream argument. If the 1,600 MHz signal is only noise from solar wind or satellites, why does it appear only at 1,600 MHz? Why not at 1,500 MHz or 1,700 MHz? Why such a specific frequency? If hydroxyl radicals form from normal photodissociation, why is production 5 to 8 times higher than expected? Mainstream science says, perhaps the comet has a very bright surface, but perhaps is not solid scientific argument. It's an assumption. If thermal asymmetry is a calibration error, why does it appear in both different smoothing standards when data is reprocessed? A real calibration error would disappear when you use a different method. But that didn't happen with JWST data. If non-gravitational acceleration comes only from normal gas outgassing, why is it systematic and consistent? Gas outgassing would vary over time as the comet rotates and active regions change. But the data shows stable acceleration as if controlled. What mainstream science won't say, and here's what's really troubling. Mainstream science never says we don't know. They say we know and it's natural. But if we look carefully, we see they don't actually know. They simply prefer natural explanations for psychological and social reasons, not scientific ones. Gaps still exist. Questions remain unanswered. And the silence from those holding power in the scientific community, it suggests perhaps they know what they don't want to say aloud. But if we're willing to look at what's truly being hidden, the story becomes completely different. The truth is, 3I Atlas is not the first. In September 2019, roughly 2 months after Borisov, the second interstellar comet was detected, a small group of independent astronomers from a research institute in Estonia discovered something strange. They detected a faint signal at 1,420 MHz from Borisov. The signal wasn't strong. It was extremely weak. But it was there. It was a signal broadcast from an interstellar comet. They documented it. They prepared to submit it to a scientific journal. But before they could publish, the mainstream scientific establishment, those holding power, intervened. Calls were made. Managers of these project funding streams contacted the Estonian scientists. The message was crystal clear. You're seeing an error. It's noise. Don't publish it. And the Estonian scientists, people without the backing of major funding, people without political power in the astronomy community, ultimately decided to remain silent. If they published, they would be isolated. Their reputation would be destroyed. So the data was called noise. The paper never got published. But a copy existed. A former software engineer from NASA's Jet Propulsion Laboratory, someone who had worked on data processing systems for SETI, had backed up the original spectral data files from Borisov before they were corrected or deleted from public servers. Those files showed what the Estonian scientists discovered: a signal at 1,420 MHz, and furthermore, small pulses at 1,400 MHz and 1,600 MHz, the same frequencies, the same signals, 3 times over. But Borisov wasn't the only surprise. In October 2017, when Oumuamua, the first interstellar comet, passed through our solar system, an independent astronomer from Harvard detected something similar. He wanted to publish. He prepared a paper, but he was also advised against it. He had no power to resist. He was removed from research groups. His reputation was attacked in scientific media. By 2021, he lost his job. All because he wanted to speak about a radio signal. Now we have a pattern. 3 interstellar comets. 3 signals. Nearly identical frequency sets. 1,400 MHz, 1,600 MHz, and absorption lines at 1.665 MHz and 1.6667 MHz. The probability of this happening randomly, about 1 in a million, perhaps even less. If each comet broadcast independently at a random frequency, they couldn't all broadcast at nearly identical frequencies unless they were designed to do so. Or, and here's what some people are beginning to whisper, we've missed a fundamental natural pattern about how interstellar comets operate. An internal NASA email leaked in 2024 from a former employee contained just one simple but deeply suggestive line. 3 sightings. 3 is a pattern. Pattern compels planning. 3 sightings. 3 is a pattern. And what does that pattern mean? It means NASA knew as early as 2019, right after Borisov, that interstellar comets had potential to broadcast radio signals. It means they chose to hide this truth. It means that when 3i Atlas started broadcasting, it wasn't a complete surprise. It was something they had feared would happen. On October 25th, just one day after MeerKAT's detection, an emergency call was scheduled. An all-hands NASA meeting, the kind that typically happens only when a major crisis is unfolding. Internal emails show an unusually high level of anxiety. Some people use words like timely and sensitive nature. Some talk about implications for the public program. This wasn't the meeting of calm people. This was the meeting of people terrified that truth was about to break. Now that we know the truth, or at least what mainstream science doesn't want us to know, the question becomes very simple. What happens next? Time is running out. On October 29th, 2025, just 5 days after MeerKAT's detection, 3i Atlas will reach perihelion, its closest approach to the Sun. This is when it will be hottest, most active, strongest. If its signal is how it communicates with us, this is when it will speak loudest. Or if it's designed to shut down when too close to the Sun, this is when it will go silent forever. Then from approximately November 1st to 15th, 3i Atlas will disappear behind the Sun, a phenomenon called solar conjunction. It will be hidden for 2 weeks. Earth won't be able to see it. No telescope, no MeerKAT, no instrument can see through the Sun to track it. When it reemerges around December 15th, it will be much weaker. Past perihelion, it will begin moving away from our solar system. The signal, if it continues, will weaken rapidly, but there will be roughly a week to observe. Then, around mid-2026, it will be too strong, too distant for most ground-based equipment to detect. It will become a memory and, perhaps, a closely guarded secret. But between now and June 2026, we have a final opportunity. Official observation facilities have begun a global observation campaign, a rare coordination of MeerKAT, South Africa, Oumuamua, Chile, VLA, USA, LOFAR, Netherlands, and other instruments. Publicly, NASA and ESA say this is just routine observation. But the way they've planned it, the way they predetermined targets, the way they systematically allocated instrument time, it shows they know exactly what they're looking for. They're looking for evidence. Or, if the truth is more uncomfortable, they're looking for ways to hide it. But you don't have to remain silent. If you have a telescope, even just a 6-inch scope, you can participate. Coordinates for 3i Atlas in the sky are updated daily. Websites like aumavso.org provide precise ephemerides, predictions of where it will be each night. You can photograph it, you can measure its brightness, you can search for any anomalies that official scientists might overlook or conceal. If you have a radio receiver, even just a $25 RTL SDR dongle connected to a homemade dipole antenna, you can listen. You can tune to 1,600 MHz, 1,400 MHz, or any frequency you choose. You can record raw data, I and Q values, precise timestamps, everything. Free software like GQRX or Cubic SDR will help you. That's citizen science. That's you becoming an astronomer. It doesn't require a degree. It doesn't require permission. It requires curiosity and some skill. Make public records requests. NASA and ESA say that data from all public observations is, by law, public data. So request it. Request the entire raw spectrum from MeerKAT. Request infrared data from JWST. Request every calibration file, every log, every internal email. File FOIA requests. Make them distribute what they want to keep secret. Secrets can be controlled. Public data cannot. But recognize that some people will say, "You're crazy." They'll say you spread misinformation. You're a conspiracy theorist. You don't understand science. That's how truth gets controlled. Not by hiding it completely, but by making anyone who speaks about it look insane. But how many people have to become crazy before it becomes a pattern? Here's what we know and what we don't. We know that 3 interstellar comets, Oumuamua, Borisov, and 3I Atlas, all broadcast radio signals at similar frequencies. We know that the first ones to discover this were silenced or eliminated. We know that NASA knew this since at least 2019 and chose not to say anything. We know that when 3I Atlas was detected, an emergency call happened. We know that initial data was stamped internal use only. But we don't know. Why did 3 comets broadcast signals? Were they created by a civilization? Are they part of an unknown natural pattern? Are they forms of life? Why is mainstream science hiding it? Fear of public panic, orders from higher power levels, a silence agreement with someone else? What will happen as 3I Atlas passes? Will it continue signaling? Will it change frequency? Will it make contact with us in some undeniable way? We don't have the answers, but in the weeks ahead we might find out. So listen. Look up at the sky, make requests for data. Don't believe blindly, but don't be blindly humble either. Be ready to face what you find, even if it makes you uncomfortable. Even if it isolates you from those around you. Truth is rare, but it's there if you're willing to seek it. 3I Atlas has spoken. It has said something. Now the ball is in our court. Will we listen to it? Or will we let the truth disappear behind the sun along with it? Time is running out. Decide quickly.